Hey everyone, my name is Gordon. Thanks for checking out this video. So what I'm going to be doing today is taking a look at some of these SQL interview questions. We'll be tackling them live with no prior reviews, no assistance of any kind. I never took any formal SQL classes or anything like that. I certainly never have looked at any interview questions related to SQL before. But I do use SQL every day on the job, so I thought it'd be kind of cool to see how a practitioner with no like formal exposure would do if you just dump them into some of these interview questions. So with that, we'll go ahead and get started. We'll be using datalemur.com. I don't know really anything about this site. I just saw it recommended as a great source of free interview questions. So for that, I do recommend it. When you come to Data Lemur, they have questions related to a variety of things, but we'll be focusing on SQL. And let's just go ahead and dive right in. So this is not meant to be educational, by the way. It's really just meant to be kind of a chance to uh, give myself some practice and also talk through my approach as I'm thinking about projects. So let's see, we'll start with an easy one, and I'm trying to see if there's one related to people analytics at least. Yeah, here we go. So let's just start with this one. FANG well paid employees. Companies often perform salary analyses to ensure fair comp practices. One useful analysis is to check if there are any employees earning more than their direct managers. Definitely experienced that before. As an HR analyst, you are asked to identify all employees who earn more than their direct managers. Results should include the employee's ID and name. Looks like we have two, no, one table. And so it's got employee ID, employee name, salary, the department ID, and the manager ID. And they want us to output a result that only includes the employee ID and the employee name for employees who make more than their manager. So right away, I can tell we're going to need to do a self join or an inner join of the employee table to itself, because what we want to do is we want to have kind of this employee table, but we want to take a copy of it and join it to itself so that we can see for each employee ID and each manager what the employee salary is and the manager salary side by side. That'll make a little bit more sense as we go through it. So what I'm going to do is I'm just going to go ahead and set up the basis for the join. So select everything employee as E1, join employee as E2. That'll be our second copy. And then what we want to select to start is I'm just going to select more than what we need so I can troubleshoot and go. So I'm going to select E1.employee ID, E1.name, and I'm going to name these to be a little clearer because we're about to join this to itself. So this will be employee ID from E1 as emp ID, name as emp name, and then we'll do E1.salary as emp salary. And then for our second copy, we are going to do E2 dot, it's going to be E2 dot employee ID as manager ID, because this will be the manager copy, and then E2 dot salary as manager salary. And so for our join, we're going to join employee as E1 to employee as E2 on E1 dot manager ID equals E2 dot employee ID. So basically what we're saying is, hey, in this first copy of our table, look at the manager IDs and then join them so that we can get that manager information. And then we will just order by, does it say what we should order by? It does not, so we'll take that out for a second. So let's just see what this gives us before we go any further. And then we'll do a quick validation. So Emma Thompson, for example, her salary is 3,800. That checks. Her manager ID is manager 6, which if we go down here, that should be Liam Brown with a salary of 13,000. And sure enough, that does come in. And we can also do E2.name as manager name just to give us that little bit of extra detail. Yep, so here we go. So that one checks. The other thing I want to check is we have some employees down here who don't have managers. These are the managers themselves, and so they should not show up in our result over here. And so I'm just going to check to make sure that we in fact do not have employees 6, 7, 8, or anything like that. And we do skip those over here on the left. And again, the reason why they are being skipped is because they don't have manager IDs themselves. Okay, so this is the first part. Now the second part is we just need to identify the employees that have higher salaries than their managers. So that's just going to be where E1 dot salary is greater than E2 dot salary, because the second copy is our manager information. So let's just run that. And we get two employees, Olivia Smith, who has an employee salary of 7,000. Her manager is William Davis with a salary of 6,800. And then similarly, Benjamin Hernandez, 9,500. Now for the final result, they only want us to provide employee ID and employee name. I just included all this other stuff so we could troubleshoot better. So what I'm going to do is I'm just going to comment out everything except that information that we need. Run it again, and let's submit. Awesome, we got it right. And then they also provide a solution where we can take a look at their recommended solution down here at the end. And it looks pretty much the same thing as we did. So they're still joining employee to itself, and they're still filtering for where the employee salary is greater than the manager salary. Awesome. Okay, let's go back and do the next one. One for one, I like it. Let's try and find another one related to people analytics. So we just did well-paid employees. Oh, a medium one, second highest salary. Okay, dipping our toes in a little deeper. Imagine you're an HR analyst at a tech company tasked with analyzing employee salaries. Your manager wants to understand the pay distribution and asks you to determine the second highest salary among all employees. It's possible that multiple employees may share the same second highest salary. In case of duplicates, display the salary only once. So out of all of our salaries, we want to find the second highest one. And if two people both have that second highest salary, display that salary one time because we're not worrying about the employees in this example output. They want us to only provide that second highest salary. So let's just take a look at what our data looks like. So we have employee ID, employee name, salary, department ID, and manager ID. So what we're going to want to do is we're going to want to rank the salaries, identify the one that is second highest, and then provide it. So this should be fairly easy. We will do, we'll select salary, and then we're going to do a dense rank over, and then we don't need to partition by anything, I don't think, so we can just do order by salary ascending, and I'm going to call this S rank for salary rank. So let's just see if this works first. I'm going to order by salary descending so it's easier to troubleshoot. I made some sort of issue. Dense. Oh, I forgot that. I think that should solve our problem. Yep. Okay, and so now we have our salaries in order. Let's just make sure that that's right. So 13,000, 12,500, 11,000, 1, 2, 3. Yep, everything's ordered correctly. And our last step is to filter for just this second one. There are no duplicates, at least at the second rank. But down here for like rank 7, we do see duplicates. So I'll pretend like we had duplicates in that second rank just so I can show you how I would handle that. So what we want to do is there's a couple ways we can do this. I think um, I'm going to do this with a CTE, and then I'll show you another way to do it. So I'm going to do with pay rank base as, and I'm going to put what we just had in there. I'm going to select from pay rank base where S rank equals 2, and I want to select just the salary, except if there were duplicates, I would need to do select distinct salary. So let's run that. And we get salary of 12,500. Let's check that that's right. It is right. Awesome. I think another way we could do this is, well, instead of using a CTE, we could use a subquery, but I hate subqueries. I think they are awful. So instead, let's just try something like this. I have no idea if this will work, but let's just try it. So instead of wrapping this in a CTE, I'm going to try having something else. I'm going to try having I don't think this is going to work, but let's just try it. I don't think you can put window functions in here, but I'm going to try it that way. Yep. Okay, so the error was you can't place a window function in the having clause. So disregard that. The answer that we're going to want is to go back to this one that we originally had. And then I mentioned you could do a subquery instead, which I hate. That would look something like this. Instead of putting a CTE, we would do select distinct salary from, and then wrap everything in there instead. Must have an alias. That's weird. Okay, so by the way, the exact syntax you need is going to depend on the exact like platform and form of SQL. This is a little bit different than what I'm used to, so I think it's just asking me to give it an alias. Let's just try that. Yep. Okay. And so we got that same answer. So two approaches, CTE or subquery, either one works. I like CTEs. They're much easier to follow, in my opinion. Awesome. Let's look for another people analytics one. Okay, another FANG one, top three salaries. As part of an ongoing analysis of salary distribution within the company, your manager is requested a report identifying high earners within each department. A high earner within a department is defined as an employee with a salary among the top three within the department. So basically, group by each department, identify the employees with the top three salaries in each of those departments. And then they want us to identify these high earners across all departments. And so we want to display the employee's name, their department, and their salary. In the case of duplicates, so in case two employees within the department have the same salary, sort the results of department name in ascending order, then by salary, and then if multiple employees have that same salary, order them by alphabetically. And so we have two tables. We have an employee table here, which we can take a look at. Looks like this: ID, name, salary, department ID, manager ID, same thing from before. And then to get the department name, it looks like we're gonna have to pull that from a department schema. So there's going to be two parts to this. There's going to be joining the department table to the employee data to get the department name. We'll join on department ID here. And then the second piece will be to rank the salaries of the employees within each department. So I think this should be pretty straightforward. So let me do this. So we're going to select from departments as D, and then we're going to stop. I hate stop. Okay, that's annoying. Okay, and then we're going to, I'll start with the left join. Probably won't end up using it, but I like left joins to start because this way you can see all your data, including failed joins. Whereas if I were to just do an inner join, I would miss any cases where a join did not succeed. So I want to select from departments as D, left join, what's the other one? Employee as E on D dot department ID equals E dot department ID. That's going to be our join key. And so now we're going to select D dot department name and then E dot salary as salary. And then the employee name. So I'm actually going to put that there. Oops, sorry, it's E dot name as employee name. I'm going to just make sure those are the final. Yeah, so they want the department name, the name, which is the employee name, and then the salary. So we're going to select D dot department name, E dot name as employee name, and then E dot salary as employee salary. And now we need to do our ranking. So it's going to be a dense rank, and it's going to be over. And now we're going to partition by department, order by salary, ascending. And now I need to add my D dot department name, order by E dot salary descending, and we're going to call this dep pay rank because it's the rank of pay within departments. And then lastly, I want to order by D dot department name. And then when they say order by name first, in ascending order, then by salary in descending order, and then by employee name. So D dot department name, E dot salary, descending, and then E dot name. Let's try that. Specified relations does not exist. Did I get something wrong? Let's just check the join first before we see what's going on. Okay, I think there's a problem with the way I called these, my naming somewhere. Okay, so our tables, let's just make sure our table names are right. So it is, there's the problem right there. It is department, not departments. So typos, very important. Okay, now we get what we expected. Now remember, I have not filtered for just the top three yet. So right now this is providing every employee and every salary. I just want to make sure that they are correctly ranked within each department. So data analytics, Olivia Smith has the highest salary of 7,000 and she does have the pay rank of 1. The next two are tied with a salary of 4,000. They have a rank of 2. I used dense rank to make sure that the next pay rank doesn't skip to 4 after this tie. If I hadn't done dense rank, if we just did rank, can show you what that would do. That would just go 1, 2, 2, 4. And sure enough, 1, 2, 2, 4. So dense rank makes it so that after a tie occurs, you do not skip a ranking place. And so the last step here is we want to filter for just the top 3. So I'm going to wrap this all in a subquery. I'm going to call this dep pay base as blah, and then we want to select from dep pay base where dep pay rank is less than or equal to 3 because we want the top 3, and they want us to provide just the department name, just the employee name. Just gonna call it name to match what they have down here, and then just the imp salary. I'm gonna call that salary again to match what they have. And perfect. And so we do see in the data analytics there are 4 results, but that is because 2 of them are tied. And I just want to make sure they didn't. Did they say how they wanted us to handle that? Yeah, it didn't say anything about filtering for just 3 people. It says they want the top 3 high earners. So if 2 people have the same salary, then I think it makes sense to count them as like one salary rank. So in other words, I wouldn't want to provide for data analytics just these 3 results because that only represents 2 distinct salaries. Okay, let's go ahead and submit this and see if it's right. Awesome. We love to see it. Let's check their solution. Actually doing better than I thought I would. We've had a few clumsiness, but overall I'm happy. And yep, they took the exact same approach we did. They have their CTE where they are, joining the two together and partitioning. Or actually, no, they did a little bit differently. So they put their join after the CTE. So first, they just worked within the employee table. They didn't worry about the department name. They partitioned by department ID, whereas I went ahead and joined a department name and then partitioned by department name. So the only difference here is, again, the exact order in which they joined in that department name. Either of these work, either of these are fine. There could be some differences in efficiency, but for like a toy small data set like this, it shouldn't make a difference. All right, we'll do one more, I think. Are there any more people analytics ones? Do. Uh, we'll skip that one. I'm going to be a coward and we'll skip the hards for now. We'll come back to it later. Actually, no. You know what? No cowardice here. Let's jump right into the hards. I am not afraid to fail in front of everyone. Let's look for where to go. I just saw that hard one about employee stuff. I swear I just saw. Oh, these are all premiums. Okay, never mind. We need to go back up here and find one that is not premium. Department versus company salary. You work as a data analyst for a FANG company that tracks employee salaries over time. The company wants to understand how the average salary in each department compares to the company's overall average salary each month. Write a query to compare the average salaries of employees in each department to the company's average salary for March 2024. And then we want to compare them as higher, lower, or the same. Display the department ID, payment month, and month, year format, and comparison result. I can already promise you I do not know how to format this exactly. I will probably use Google to get the code for that. But the important thing is the concept, not the exact syntax and grammar. So as our example output, well, first let's look at our inputs. So we have the employee table that we've been using, and then we have the salary table where we can get for each employee ID, their payment date. So we can see the payments end time, and we're going to want to filter for just March. And so in this case, it provided a case where the payment date, let me make sure that's right. Hold on. So they want to, okay, so they want us to calculate the average salary of employees in each department to the company's average salary for March. So yeah, so this toy example is just using January as an example, but we want to use March. I was just confused there for a second. Okay, so the goal is to calculate the average within each department and compare that to the overall average. So I'm going to do this very inefficiently. I'm going to start by just filtering for March. So payment date, let's just see what our distinct payment dates are first, because I want to see if they're all formatted where they're like on the last day of the month or not. So I'm going to select distinct payment date from salary and then order by 1. So let's just see what our payment dates look like. Okay, so they are all on the last day of the month, and for March that's going to be 03/31. So I could just do a filter for payment date of exactly this, but let's do something instead. Let's do it from salary, where payment date is between 2024 03, 01, and 2024, 03, 31. So this would help us account for if we did have March payments that weren't on the just the last day of the month, this would capture those. So this is a little bit more, generalizable and robust. Okay, so that is constraining everything to March, and we need to get departments, payment dates. Okay, so the department data is here. And in order to get the payment date, we have to join the salary to the employee data by employee ID. Okay, so let's just start with that. We'll do this in pieces. So we'll do from employees as E, and I want to select, all right, then we'll go do our join. And then I'm going to do an inner join. I normally don't, but we're going to do an inner join because we have to have that payment date. So if there's any records where the payment date was null, for example, or there's any records where we couldn't match the employee to their payment date and salary, then we wouldn't include them in this analysis anyway. So it doesn't matter if you go ahead and use an inner join this time. So we're going to do from employees as E, join to salary as S, and our common key is going to be the employee ID. Yes, and that's the only, I was making sure there weren't any other common keys, but there are not. So on E dot employee ID equals S dot employee ID, and let's just test our join and our where clause first. So I'm just going to select E dot employee ID, E dot name. Even though we're not going to use all of these, I'm going to go ahead and pull them in for troubleshooting. E dot manager ID, and then S dot salary ID, S dot amount, S dot payment date. Let's just do that first. I bet I spelled it wrong. Yep, it's employee, not employees. Another typo. Okay, so it looks like our join worked and our filter for payment date did work because these are all March dates. And so we have successfully gotten a list of every employee payout in March. Um, and it looks like there are no repeated employee names. So every employee has exactly one, payment in March. And so our next step is we want to calculate the average department salary within March. So I'm going to back out all of this and I'm going to do average uh, S dot salary on, no, sorry. We want it by department. So E dot department ID average S dot payment, wait, S dot amount. I don't like how some of these names change in between questions for the same data. Okay, so we want to select the department ID and then the average salary amount as average salary in March, just to be explicit. And we need to add a uh, group by E dot department ID. Let's just see if that works first. Perfect. Okay, so for each department ID, let me order by. And then let me also round salaries. So we're going to do round the two decimals. Do they specify what they want? Oh, right. We're not actually going to provide the amount later. We're just doing the average. Okay, so for each department, these were their average salaries in March. So I'm going to copy this. And then what I want to do real quickly is I want to validate one of these and make sure it's roughly right. So for department ID 1, it's saying in March we had an average salary of roughly 4,800. So I've copied everything we just typed, and I'm going to try and go back to the, it's going to be annoying. Bear with me for 1 second. Okay, I'm going to go back to this. Again, I'm just trying to validate that what we looked at a second ago was right before we go any further. Okay, so for the department ID 1, it was an average of 3,800, and that's going to be these first 6 rows. So we got 4,000, 4,000, 7,000, so that's 8,000, roughly 10,000, 17,000. It's going to be 19,200 roughly. And then it's going to be 23,000 divided by 6, which is just shy of 4,000. And we said the average was 3,800, so perfect. Looks like this that we just did was accurate. Okay, so this is by department. We also want to do this for March. So what I'm going to do is I'm going to put this in a CTE with dep average pay as blah. Now I want to calculate the overall average. And so what I can do is actually, I'll tell you what. Um, let's just, yeah, bear with me for a second. So we're going to do the exact same. Just trying to think. So, okay, sorry, just trying to think the best way to get the overall company average in March. And I think for this one, there's a couple different ways we could do it, but I think the easiest way is just going to be to pull it directly from this salary. So, salary, where payment, and it's going to be just as average company salary in March. Okay, so basically we're saying select the average amount from salary in March, and that's going to be our March average. Okay, so our March average is 7,212. And so now I need to figure out a way to join these two because remember our goal, let me just copy all of this. Our goal is to compare this overall company average to our department averages that we got here. And we want to see which of these is better than that company average. And remember, our company average was, what did we say it was? Company average was 7212, and the department average is here. So it looks like which ones were higher than the company average? 7121. I swear, my memory is awful these days. Sorry. 7212. So 7202. Copy, copy that, and then go back. You guys are really seeing the limits of my SQL here. Okay, so it looks like these bottom two, departments 2 and 3, did have a higher average in March. And so now I just need to figure out a way to produce a final result that actually does that. So let me think. What is the best way to do that? So let's put this in a CTE, average company pay. And so we want to do. Oh, actually, I think there's a couple different ways we could do this. I think one way might be to do it would be bear with me, maybe something like this. I have no idea if this is going to work. Let me see if this is going to work first. I'll explain what I'm doing if this works. I'm trying to just create a random identifier. I know this is not the efficient way to do it. Okay, good. And so what I'm going to try and do is I'm going to add the same one to the second CTE we did and then join together on that. This is definitely not necessary to do it this way. The way I typically approach problems is to do a way that I know works and then I try to make it efficient later. So now I'm going to do the same thing and add this one as column D to the company average pay. And so let's just make sure it worked by doing select all from average company pay. Yep, so we added that one there, and now we can join on these, and then we can do our case when logic to do the comparison. So now what we'll do is select from depth average pay as D, and then we'll do a, that's so annoying. And then we'll do a left join to average company pay as C, and we're going to join on d.call_id, which is literally a 1 that I added for the purposes of this join on d.call_id equals c.call_id. And then let's just do d.star. Let's just make sure the join works before we go any further. So I'm telling it to select everything from these two. And perfect. Okay, and so now this last step is now that I have the average salary for each department side by side in March, I'm going to add a case when statement that says, hey, whenever the average department salary was higher, then say lower. So now I'm going to do d dot department ID d dot average salary in March. And then C is just going to be the average company salary in March. And now we'll do case when D dot, I should not have made these names this long. So case when D dot average salary in March is greater than C dot average company salary in March, then what do they say should be higher. So when the average department is average is higher, then we're going to call it higher. And then let me actually do this because we're going to have multiple of these. And so the next one is going to be when the average is equal to it, then it is same. And then when it's lower or less than, then it will be lower. We'll make sure this works, and then we'll do the final formatting to give them what they want. Uh, error. Oh, duh. Else error in as comparison. Okay. And so, sure enough, I did misspeak earlier. I said 7150 was higher than 7212, and I had said incorrectly that our final result should flag both departments 2 and 3. We can see that's not the case. 7150 is in fact less than 7212, so the only one that was higher was department 3. Now, for their final result, they want just the department ID, the comparison, and the payment date. Um, the payment date I did not provide. So what's the easiest way to do that? Da, da, da. So E dot department ID. So maybe, well, they're all in March, so that's kind of I'm not going to say dumb, but it is kind of dumb to do that, to require that. So I'm just going to manually type this in as, so they want the department ID, and then next, so I'm just going to manually type in 03/2024 as payment date. Let's see if that works. It did work. Again, this is kind of cheating, but in my opinion, this is a dumb part of the interview question. Not dumb, it's just unnecessary because you're already filtering to where everything is March. So I see no reason to also put March in the result. But we'll do a little bit of cheating, and this also gets around the requirement to format it via a special formatting to go from this right here, this format, to their desired format of month, year. So we're skipping some steps, but the meat and potatoes is really calculating the average for the department, calculating the average for the company, and then identifying where one is higher than the other. Okay, and so they only want the department ID, our fake payment date, and then comparison. So I'm going to comment out everything else. And then the last step is going to be uh, where D dot average salary in March is greater than. Okay, so department ID number 3, payment date March 2024, and the comparison is higher. Oh, it was wrong. So they were expecting, oh, so they did want all of them. I don't know why they asked for, okay, that was kind of confusing. So we did it right. I just need to remove that filter I added at the end. So now let's run our code. And now we have the same 1, 2, 3, where they say 1 is lower. We have 1 being lower. 3 is higher. That's the only month where it was higher. We have 3, and then they have 2 being lower. I'm not sure what they ordered by. They didn't order by anything. So I bet we're gonna get an error because mine is in 1, 2, 3, whereas their solution is in. Whoops, sorry. Let me submit this first, and then I'll explain. Okay, so we're still getting errors, but that's just because of this weird order by. So they're expecting it to be ordered by 132. Ours is ordered by 123. I don't understand where they got this ordering from. I have a feeling that it's just their solution. They probably ordered by something in one of these CTEs, but it doesn't matter. Even though they say we got it wrong, we did in fact get it right because we correctly identified that Department 3 in March is the only month where the department average was greater than the company average. So boom, this was really ugly, this last one, but I told you I would do it live and I would not chicken out. So True to my word, if nothing else. Thank you for bearing with me. This was fun. I might do it again in the future. We'll see. Let me know if you liked it, and it was definitely good practice for me. Thanks for watching, and hope you all have an awesome, awesome day.